Thank you, Cliff and George. As George and I mentioned, our content this week is European-focused, so we would be remiss not to have OVH on the stage. As the largest data center operator headquartered in Europe, they have a fantastic perspective to share with us. So please join me in welcoming OVH Global Environmental Director, Grégory Lebourg.
Hello, good morning, everyone. Bom dia, like they say in Portugal. I'm super excited to start these keynote sessions with a very important topic, which is sustainability. I'm sure you're aware of, but our industry is under the spotlight as we speak, considering our impact on the environment all across the board. So what I would like to do in the next 12 to 13 minutes is to walk you through, first, the problem statement. What is the impact on the environment of our industry? And then what are the levers we can globally activate? And when I mean globally, I'm talking about all the value chain, all the ecosystem that should be set in motion to make it happen. So, just to start with, what is the environmental impact of the ICT sector? I'm referring to a study that was released early in March last year that was based in France, but it's quite the same worldwide. Basically, it's a multifactorial thing that we are looking at. In that study, they have considered 18 factors, 18 different impacts on the environment, and they have gathered them up in, four main pillars of impact. The first one, which is very famous, it's about the climate change, it's the carbon footprint. The second one is our eagerness for resources, resources in general. It can be water, it can be earth, whatever. Then there is, more specifically, the needs for abiotic resources, all the minerals that we need to make the cloud work. And then, obviously, there is the power consumption. To feed those systems, we need a lot of energy, okay? So whatever the angle you take, whatever the type of factor you're considering, globally, you see that it's growing exponentially, okay? And these are the forecasts for the evolution by 2050 that shows that, again, all across the board, we are more than doubling our impact on the environment. Let me give you some concrete numbers to illustrate the point. Let's say 2–3%, that's the ICT sector contribution to the greenhouse gas emissions in 2020. If we keep on like that, it will be 3 times that number by 2050. Look at that. For the last 3,000 years, we have excavated minerals, right? We needed copper, we needed iron, whatever mineral. But if we look at what we need now and what we will be needing in the next 27 years or so, it would be about the same amount of minerals to be excavated from the ground. And this is not only for ICT sector, it's as well for the new ways of producing renewable energy and for mobility. 2.5% in 2020. That's the ICT sector global demand for energy. There again, with the trend that we witness today, it will be more than doubling by 2050. More interestingly, because not very often we talk about that one, 5 billion cubic meters, that's the amount of water which is just needed by artificial intelligence. And again, it's a niche use case in our industry. But this is about the global consumption of water of a country like France for everything, residential, industry, or agriculture. 1,400 plus, that's the number of data centers already in operation in Europe. And if we look at all the building permits, if we look at the dynamic of the industry, there would be probably more than 100 popping up by 2026. And this calls for a lot of resources as well. So, how do we, in OVHcloud, tackle that issue? So basically, we're addressing the 4 main impacts that were shown before. We are tackling the climate change impact, CO2 emissions, the water stress, the resource depletion, and the land artificialization. This 4th one is very put aside in the industry, but I think that there is quite an interesting challenge in terms of finding land and finding ability to build new data centers in the future. So what are the mitigation levers that we contemplate? Number one, The mother of all is to extend the lifespan of the devices, extend the lifespan at the component level. So what we do in OVHcloud, we are vertically integrated. We design and manufacture our own servers. So we have the ability to put in place what's called a reverse supply chain. So let's take an example of a server having a first life for 3-4 years in the data center, then a second life, pretty much the same way it was built, with a bit of upgrade or downgrade. After 9 years, we can send it back to our factory and disassemble everything. And what we do is that all the components that are retrieved from the hardware profile, we test them and make sure that they are working properly. And if they are working properly, and if they fit in the new hardware profiles that's going to be released in our data center, we just put them back in stock. The way to measure it is the reuse rate ratio, and last year we achieved a 36% reuse rate ratio on the component side. These are components that you don't need to manufacture from scratch in the first place. So call to action to the ecosystem. We do it because we are vertically integrated, but there's no blocker, there's no rational blocker not to make it happen, even though you're not integrated vertically. It's just a call for action between the cloud service providers and the hardware manufacturer to put that into motion, even going the route of third parties to make it happen. One enabler as well is to have, from scratch, the idea in mind to design the servers so that they can be easily dismantled, bringing down the cost of disassembling downstream. And then for the rest of the components that can't be reused because they are not functioning well or they are useless, the idea is to invest in downstream processes to recycle the minerals inside. There are a number of startups on that market. We do accompany them. It's very important that you have a look at the new pyrolysis and electrolysis processes, which are very, very efficient today to recover most of the material, even in tricky components like motherboards. OK, the first thing is to be efficient as well. So on the CO2 front, what we've been doing since the last 20 years is to go for water-cooled servers. Again, easy for us because we are manufacturing our servers. It's easy for us to fit them out and to put the systems on top of it. This is definitely the route the industry should be taking. Considering the boom of AI, considering the power at stake in the processors on the market, water cooling is highly efficient. Okay? So just to illustrate the point, our global PUE worldwide, if we look at our 42 data centers worldwide, it's 1.27. And with the latest technology that we have implemented, we can be in a position to reach 1.15 as a PUE. So you see, it's only via closed circuits that we capture the heat at the source on the CPU side. For the rest of the components, we are using an airflow, which is captured at the back of the rack. It's not rocket science. It's quite easy. So how do we make it happen collectively? Number one, those CPU and GPU should be designed so as to ease the water block installation. Okay? If they are fit for purpose, it's even easier for us. Very important to have a collaboration between the chip manufacturer and the server manufacturer to ensure that the cooling performance would be considered so as to maintain the standard warranty. It's very important in terms of operations. And more interestingly, we have to put together this value chain and create bonds between the stakeholders, from the chip design to the mass production, going through the CFT analysis, prototyping, proof of concept. We should work together in the ecosystem. Plus, it would be interesting to have a long-term visibility on roadmaps, to be always a step ahead and plan the water strategy, the water cooling strategy, before the chips are released on the market. Water frugality. We use water to cool down the systems at the end of the chain. Mostly, the industry is relying on cooling towers, and they are very thirsty. But there are alternative solutions, such as dry coolers, and these are the ones that we implement in our data center. What we do, though, is we have a water profile that allows us to only use adiabatic cooling when the outside temperature is above 25 degrees Celsius. Okay? Because our water is from 27 to 47 degrees Celsius outlet. By doing so, we have a WE of 0.3 liters per kilowatt hour to be considered versus the worldwide average of the industry, which is 1.8 liters per kilowatt hour. And if, again, we look at the latest solutions, we are as low as 1.1 liters per kilowatt hour. It's a very simple technology. It should be very interesting to deploy that at scale. Ecosystem call to action on this one. Today, the dry coolers are very expensive, number one. Two, the dry coolers, they're working with a delta temperature which is very low, very often 5 Kelvin or 10 Kelvin. The higher the delta temperature, the lower the power you need on the fans, the better you're off with the energy efficiency. So they should work on this one at the design stage. And then they should generalize as well the cooling pads so that when we evaporate water, we do so through humid media instead of evaporating on the dry cooler itself to recycle the water which is not evaporated. That's very important. Number 4, immersive cooling. I'm sure you'll hear about immersive cooling in the day. That's very interesting because the technology I was presenting can cope with racks up to 50 kilowatt. With that technology, we can go up to 100 kilowatt, which is a perfect fit for artificial intelligence, for example. With this solution, where you immerse the server in a dielectric fluid, oil, you have the ability to reach very interesting partial PUE. Almost no energy needed to circulate the thermal convection. And the beauty of this system is that you can work at higher water profiles, meaning that if you can have an inlet temperature of 45 degrees and an outlet at 65, you don't need evaporative cooling anymore. So ecosystem, a lot of things to be done on that field. Number 1, decrease the cost of dielectric fluid. It's still too expensive. It should be compatible with all the IT equipment immersed. It's not the case today. It should be biosourced as well. We have to consider that from scratch. We have to work on the flash point for security reasons while maintaining a proper viscosity. We need to make sure that the lifespan would be extended. We need to make sure that it should be recycled properly, and so on and so forth. So a lot of things to do on the R&D side on this new technology. Last but not least, land use. You know, data centers they are factories. They take space. We see too many greenfield approach today in the design. We should favor brownfield approach, okay? If you look at the example of OVHcloud, out of the 30 data centers that we have built ourselves, only 26 are brownfield, meaning that only 4 of them were greenfield, where we started from a virgin piece of land. This is feasible, okay? And you've got an example on the screen for a Rio Tinto factory that was in Beauharnois in Quebec. So call to action is very simple. Guys, whenever you plan a data center, work with your engineering and consulting firms, make sure that they have some revamping approaches in mind. And it's very interesting in terms of go-to-market, because the building, the land is there. So basically, by the time you acquire the space, it takes only 6 to 8 months to make it happen and sell the first services. Thanks for listening. Have a good day.